I'm Ethan Kwan, and today I'm going to be talking about black holes. What are they, how they get formed, and are they dangerous? Okay, so here is a black hole. Do you see it? Okay, fine. Let's make something fall into it. 2 stars. Okay, so here are a few stars being sucked in by a black hole. And yeah, so let's just wait until this animation finishes. As you can see, this is just water and algal dew colored and sucked into a black hole. Okay, so before we start the video, I want to clarify 2 things. First, will Earth be swallowed by a black hole? No. The closest black hole to Earth is called A0620-00, but this is 3,300 light years away, so not close enough to be dangerous to Earth. Second point, a black hole is not a cosmic black vacuum cleaner that suck everything up. I'll explain why they feel like they suck later in this video. Okay, so how do black holes form? So this is how black holes form. They form when huge stars, much bigger than our sun, blow up, literally. They go supernova, which is a fancy term for star exploding, and so it collapses, and that core of the star gets squished so much that it will go supernova. The neutrino radiation is so big that it will push out these layers and it will explode. Okay, and the black hole is left. Here's a better animation of what happens from the Discovery Channel. So this is a star going supernova, and this is what would happen if we saw a supernova through a telescope. Now, of course, this is an artist rendering. Okay, so now let's explore the parts of a black hole, ignoring, of course, the obvious ones like a star. Okay, so let's address the parts of a black hole. So there is a black part and there's a hole part. No, literally. So the black part is what's called the event horizon. This is the edge of a black hole, and this is the point of no return. So you can think of it like a waterfall, like if there was a kayaker or a swimmer swimming closer and closer toward the waterfall. Once they pass a certain point, it will be impossible to climb up the waterfall to safety. Now, that's kind of a gruesome example, but still, it works. So this is kind of the same, but since it's black, no light can escape. So that's why it's called a black hole. So what is the hole part? Well, the hole part is called the singularity. The singularity is basically the very center of a black hole, and it's thought to be zero radius and 0 surface area, but infinite density. Okay, so what is the glowing red stuff around the black hole? Well, that is what is called the accretion disk. And that is basically all the leftover stuff that hasn't fallen into the black hole yet. In fact, a lot of stuff doesn't make it into the black hole. About 50% of the stuff get shot out by the relativistic jets, and these are these pole-like things that are coming out. So you can say, I guess you could say that a black hole is a very messy eater. That's a way of knowing it. So it just sprays food all over the place as it eats. Not literally. Okay. So let's address the next question. Why do black holes suck, literally and figuratively? Okay, so we know that everything falls here on Earth. If it's a tree, a ball, a rock, even a house, or even some water, right on cue. So that is all because of gravity. Gravity pulls everything down with it. So that is what's happening in this animation here. And it's basically algal dew. So anyway, So that is gravity. So technically, a black hole doesn't have sucking power. It just has really, 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 really strong gravity, and I guess this would work. Okay, so it's really strong. So we have to explore a concept to see why everything gets stretched out when we go near a black hole. So here's a star being ripped apart by a black hole. And as you can see, it gets squished. It literally gets squished, and it also gets longer as it goes toward the black hole. And right now you cannot see the black hole because it's black, obviously, but it's kind of possible to see it. So why does that happen? Why does it stretch out and become very long? Well, this is the best way of explaining it. Look at the star. At the start of the animation, and I labeled the black hole for you, so it's easier for you. So that point, the white point on the star, is closer than the other side of the star. Yeah, duh. But it becomes more apparent that there's more gravity on that side. Now, if we go to the next slide, we'll see that this is kind of in the middle of the stretching up process. Now this first point is a little bit farther from the other point, which means it has more gravity than this point, right? And lastly, if we go to the last part, as you can see, the first point is really, really close to the black hole, and the other side is really, really far away. So that means that side will get pulled faster and faster and faster than the other side. So scientists have come up with a name for it, and it's probably the best name in all of science. And okay, I'm going to tell to you. Wait for it. It's called spaghettification. Literally, because everything that goes close to a black hole will get stretched out like a piece of spaghetti. Technically, if we have a probe going next to the black hole, it would get stretched out until it was an atom thick. But it's literally a piece of spaghetti. So here's another myth. Lots of people think that if something turns into a black hole, it will have more gravity. But that is a myth. Let's just say, for some reason, the sun decided to turn into a black hole with the same mass, losing no mass. That means the gravity will exactly be the same. It'll turn into a black hole. That means the gravity would be exactly the same, so the planets won't actually be sucked in. It'll just keep orbiting, and the only downside is that Earth would freeze to death. By the way, if you're wondering how big Earth has to get to turn into a black hole, it has to get about 1 centimeter to 2 centimeters in diameter to become a black hole. So imagine squeezing the entire Earth into a volume or a diameter of about a golf ball. So that's when it would become a black hole. Okay, so let's look at different types of black holes now. So there are 2 types of black holes that we've discovered anyway. There is a stellar mass black hole, and there is a supermassive mass black hole. The stellar mass black holes are what you normally see in illustrations and pictures. And the supermassive black holes, this is an artist picture, but it might look like this. They are super huge, and they literally are the biggest things with the most mass in the universe, except for galaxies, of course. Okay, so where do these giant monsters live? They live at the center of every galaxy we've found, including our own galaxy. Our own galaxy's black hole is called Sagittarius A star, and it's about 43 million times the mass, 4 million times the mass of the black hole, our sun. So that actually gives us a new unit to work with. Let's say that the mass of our sun is 1. So what would this unit be called? Well, scientists call it 1 1 solar mass, or 1 SM. So that's what I'm going to be using here too. So now let's compare the smallest to the largest black holes. So, what is the smallest black hole? Well, the smallest black hole is called XTE J1650-500, and it is at approximately 3.8 solar masses. So that means if you cram about 4 suns together and turn that into a black hole, it would be about the smallest black hole ever discovered. Okay, and let's look at the largest black hole. The largest black hole is called Holmberg 15A, and it's about 40 billion solar masses. And the diameter is about 1.3 times 10 to the 11 kilometers, or 7.8 times 10 to the 10 miles, or 0.013 light years. That's actually really long. Okay, and so that means that if we put the Kuiper belt, well, if we compare this black hole to the solar system, the Kuiper belt would look like that. That would be the Kuiper belt. That would be the Kuiper belt. So this black hole is huge. Okay, so this is my introduction to what a black hole is and how we've discovered them and what the biggest black hole is, what the smallest black hole is, and what would happen if the sun turned into a black hole. Thanks for watching. I hope you liked this video. If you did, please subscribe, like, and share this channel with others. Also, please remember to like this video, hit the thumbs up button, and see you next time. Oh yeah, see how to do stuff with Ethan.com, and see you next time. Bye.